Hello, my dear students. This is your Shweta madam, and welcome to online classes. Today's concept is linked list. We have already learnt about the stack and the queue concept, which are declared and used using array representation. It may be stack or a queue. It is a static memory allocation. What is a static memory allocation? Depending upon the user's need, the memory allocation is not going to enlarge or it is going to shrink. For example, the queue. The queue is declared like this, queue with the size of 5. So this is 0 to 4, the size of 5. So in this, we have inserted only 3 elements, 10, 20 and 30. Even though 2 spaces are empty, we cannot utilize these 2 spaces for any other purposes. So this is one disadvantage. If I want to insert 7 data elements into this queue, it is not possible. Why? Because we have declared with the size 5. So depending upon the user's need, the memory size is not going to shrink or the memory size is not going to increase. The memory size is fixed one. That's why the name static memory allocation. The disadvantage is inefficient memory utilization. The memory is not utilized properly even though it is empty. That's why the dynamic memory allocation concept has been introduced. What is dynamic memory allocation? Depending upon the user's need, the memory size is going to increase or it is going to decrease. Example, even though the size is declared with the 5, I want to insert the 7 elements, you can insert because it is a dynamic in nature. Or if I only fill this queue with only 3 elements, 2 spaces are empty, I can utilize these 2 spaces for any other purposes. That is the concept of dynamic memory allocation. The advantage is efficient memory utilization. So, to adopt this dynamic memory allocation, linked list has been introduced. What is linked list? As you know, it may be stack or a queue or an array. It is a collection of sequential data elements. But in the linked list, you can store the elements anywhere in the memory. That's why it is a non-sequential collection of data elements. Non-sequential name itself suggests it is a non-sequential one. The data items in the linked list are not in a consecutive memory location. Let us go with the example. See, this is an example of linked list. This is the example. The linked list start with the pointer start. It is a pointer. Pointer tells the address of the next node. So actually the start is having the value 1000 because it holds the address of the first node. The first node's address is 1000. So what is a node here? Actually the node is having the two parts. One is a data part, another one is a link part. Data part, here we can specify the data. The data may be anything. The data may be number, the data may be character, the data may be string, the data may be date. Anything you can save here, that is the data. The pointer is holding the address of the next node. Okay, so the pointer is having the address of the next node. What is the address of the next node? The address of the next node is 2000. So here this pointer is actually having the value 2000. So that we are going to learn in next sections complete in detail. Okay, so now it is a linked list having the start indicates the start of the linked list. It is having the address of the first node and the linked list is ended with the null pointer, that is a 0. Okay, so linked list, now it is a non-sequential collection of data items. You can save the data items anywhere in the memory. The advantages of the linked list. As we already know, linked list is dynamic memory allocation. It may increase its size or decrease its size depending upon the user's need. So that's the first advantage. Linked lists are dynamic data structures. So as it is a dynamic data structure, memory is utilized properly. The second advantage is efficient memory utilization. The third advantage is insertion and deletions are easier and efficient. Why? Because when you go to the stack or a queue, you can insert the element or delete the element at a particular end. Either it may be a starting or it may be an end depending upon the cases. But in the linked list, you can insert the element at the starting here, or at the end here, or at the specified positions in between these two nodes. You can insert here, you can insert here, you can insert. For example, I can insert the 15 data item with this particular node. So that we are going to study in detail in again next sections. So that's why that is the third advantage. Insertion and deletions are easier and efficient. The disadvantages of the linked list: more memory is utilized because we are saving the elements in different memory locations, and it is complex in accessing a particular data item. I want to insert 30, so this is little bit complex as it lies very much middle in between of the linked list. So that's why complex in accessing a data item. So these are the two disadvantages. So here what we have learned is what is static memory allocation, what is dynamic memory allocation, the definition of the linked list, and the example, the advantages and the disadvantages. The next topic is components of a linked list. There are 5 components of the linked list. The first component is node. Node, it is a structure containing field. Each node is consisting of 2 fields. One, see, this is a node representation like this. This is a node representation. The first one is a data field and the second one is a link field. Here you can save any type of data. It may be character, number or a string. For example, I can save here A as a data, and the link is having the pointer which is having the address of the next node. So that is a link. So data contains an actual value to be stored and processed. This is the actual value which we are going to store and processed, and link contains the address of the next data item. The next node's address we are going to specify here. So what is pointer? The address used to access a particular node is called as a pointer. These are the pointers. Again, we are going to learn in the example. These are also called as a logical links. These are not a physical links. These are logical links because as the elements are going to be saved in different memory locations, not a consecutive memory locations. See the example again. This is the example. This is a linked list consisting of 4 nodes. First node, second node, third node and fourth node. The first node's address is 1000. Second node's address 2000. Third node's address 3000. Fourth node's address 4000. The data of the first node is 10. The data of the second node 20. The data of the third node 30. The data of the fourth node 40. What is this field? This is a link field. The link field is consisting the address of the next node. The address of the next node is 2000. That's why 2000 is specified. Here, the address of the next node is 3000. That's why 3000 is specified. Here, the address of the next node, that is 4000. That's why the 4000 is specified. But at the last, there is no last node. So that's why it is represented with a 0 and a null. So what is null pointer? The link field of the last node contains 0. See, the link field of the last node contains 0 rather than the address of the next node. As there is no next node, that's why it is a 0. That is a null pointer. Null pointer indicates the end of the linked list. So this is about what? This is about the second component of a linked list. The third component of a linked list is an external pointer. It is the pointer to the very first node in the linked list. It enables us to access the entire linked list. In above example, you can see the start is the external pointer. The start is holding the address of the first node. That's why it is an external pointer having the address 1000. The third component of the linked list is an empty list. As name itself suggests, the nodes are not present in a linked list. That's why it is called as an empty list. See, for example, the external pointer is there, that is start is there, null is there, start is there, end is there, but there are no nodes. That's why this is an empty list. That's why we have to take this as start equal to null. Observe, start equal to null. The fifth notation of the linked list, that is notation itself, If P is a pointer of a node, then notations are, actually there are three notations. One is a node, second one is a data, third one is a link. For example, if I take this particular example, if I take node 2000, see, this is node 2000. 2000 is the address, that's why node 2000. Data of 2000, what is the data of 2000? That is 20. Link of 2000, what is link of 2000? That is 3000. So these are the 5 components of the linked list. What are those? One is a node, another one is a null pointer, the third one is an external pointer, the fourth one is an empty list, and the fifth one is a notation. Let us take the last example. So this example also I have taken the 4 nodes. You can increase or decrease the nodes. Here I have taken the data types in a character manner, A, B, C and D. So first node data is A, second node's B, third node's data is C, fourth node's data is D. What is the address of the first node? These are the addresses. Addresses of the first node is 500, address of the second node is 600, address of the third node 700, address of the fourth node is 800. What is this? This is the link field which is holding the address of the next node. So next node's address is 600. That's why we have mentioned 600. Here the next node's address, that is 700. Here the address of the next node, that is 800. Here no nodes are present. So that's why we have mentioned it as a 0. So when I take the notations node, data and link, node of 600, this is node of 600, data of 600, what is data of 600? That is B. What is link of 600? Link of 600 is 700. So this is all about today's class, introduction of the linked list with the components of a linked list. Thank you.